Okay, in this video, we're going to learn about the concept of degrees unsaturation, abbreviated as DUs. It's also called the double bond equivalence, DBE, and these really mean the same thing. So different textbooks will call this calculating degrees of unsaturation or double bond equivalence, so either DU or DBEs, and they mean exactly the same thing. So essentially what we're going to do is if we're given a molecular formula, right, we can use this mathematical formula I'm going to give you, our DU or DBE formula, and then that will return a whole number. And this whole number here will tell you how many pi bonds and rings your molecule has. All right, so from a molecular formula, you can use the formula I will give you in a few minutes to get a whole number, and that whole number tells you how many pi bonds and rings you have. All right. So before I give you the formula, let's just make sure we understand how to see or calculate how many pi bonds and rings. So I'm just going to draw a few structures here to make sure that this is clear. All right. So if we look at the structure here, I don't need to figure out what the formula is. I can just look at how many pi bonds and rings we have, right? So you can see here we have one ring, right? A 6-carbon ring. We have a pi bond, 1, 2, 3. Here's a 4th pi bond and a 5th pi bond. So this molecule has one ring, plus it has 5 pi bonds. So this would return a value of DBEs or DU as 6. Okay, as 6, all right? If I took a structure like this, here we have an alkyne. Let's add an OH here. We'll say we have a double bond to N. And then let's add a 5-membered ring here. Okay, so this structure here, right, if we look at this, we have one ring, one pi bond, and then a triple bond has 2 pi bonds, right? So we have 3 pi bonds plus one ring. So if we followed the formula here, that would get you a whole number of 4. Okay, a whole number of 4. So if you're given this structure, you can just count how many rings and pi bonds you have, right? That's pretty simple. Okay, but that's not really how this is done. All right, so let's look at the formula on how we calculate this. So to calculate your DUs or DBEs, right, you're going to look at your molecular formula, and you will count the number of carbons you have plus 1 minus the number of hydrogens you have plus the number of halogens divided by 2 plus the number of nitrogens you have divided by 2. Okay? So it's the number of carbons plus 1 minus the number of hydrogens plus halogens divided by 2 plus the number of nitrogens you have divided by 2. Okay? So that's the formula to calculate your DUs or DBEs. So let's just look at a couple of examples here. If I have a formula C9H9BRO, so here I don't have the structure. To help solve the structure, I can calculate the number of DUs or DBEs. So my formula here would be the number 9 plus 1 minus the number of hydrogens, 9 plus 1 halogen, right, divided by 2. So there's no nitrogen, so we don't use that nitrogen term. And then you should notice when you have oxygens, we can basically ignore oxygens. Because oxygens are divalent, they don't show up in our formula, so you don't have to worry about oxygens. So if we figure out here, we have 9 plus 1 is 10, minus 10 over 2 is 5, 10 minus 5 equals 5. So this structure of C9H9Br has to have some combination of 5 pi bonds plus rings. Some structure of 5 pi bonds plus rings. Okay, so we don't know how many of those are, but this information can really help us figure out structures. So that's why DU and DBEs are useful. This information can help us try to determine what the structure is. Okay, so anytime we're trying to figure out the structure of a molecule, if you're given the formula, the first thing you want to do is calculate our DUs or DBEs, right? So we can just have a general idea of how many pi bonds or rings we have. Let's look at another example here. Let's say I had something that had the formula C6H8ClNO. So if that's our formula, let's calculate how many pi bonds and rings we have. Number of carbons, 6, plus 1, minus the number of hydrogens plus halogens. We have 8 plus 1 divided by 2, plus the number of nitrogens we have, one of those, divided by 2. Okay, so here we have 7 minus 9 over 2 plus 1 over 2. Okay, and these are not in parentheses, right? So we have 7 minus 4.5 plus 0.5, right? So that would be 7 minus 4, and that would be 3, right? So we would have in this molecule has to have 3 pi bonds plus rings. Okay, so it could have 3 pi bonds, it could have 3 rings, it could have 2 pi bonds and 1 ring, it could have 1 pi bond and 2 rings, right? And then again, we said 3, 0, or 0, 3. And this information can really help us figure out a structure. So we're going to be talking about infrared spectroscopy, and a lot of times if we're given the formula, we might need to draw a structure that fits the IR spectrum. So anytime you're given your formula, the first thing you want to do if you need to solve a structure is calculate your DUs or DBEs.